Welcome to lesson 14C. And in 14C, we will be describing for you case 1, where a company borrows $1,000 today, and they will repay this loan back at the end of 3 years along with interest. But the key here with case 1, all of the interest is going to be paid back along with the principal at the end of 3 years. So let's take a look here at case number 1, where we call this compound interest note with interest paid in full only at maturity. So here we have a case where today, let's have the period in, number of periods equals 0, we borrow 1,000. At the end of year 1, n equal 1, we pay 0 interest. At the end of year 2, we pay 0 interest. But at the end of year 3, we pay interest at 10%, which has been compounded annually, and we also must repay the maturity value of $1,000. So take a look here. If we borrow 1,000 today, and we owe interest of 10% at the end of year 1, and then it grows at another 10% for year 2, and another 10% for year 3, the time value of money equation, where 1,000 times 1 plus 0.10 raised to the third power equals 1,331. So the difference between the 1,000 and the 1,331 is our interest, our compound interest. And so let's take a look at a note. If we actually had a physical note, it would look like something in yellow here. And XYZ Company is the borrower or the issuer. It borrows $1,000 today on January 1, 2012. It agrees to pay 10% annual compound interest with interest payable in full, in one full payment at the end of the loan term here. And at the end of the loan term right here, it's going to be 12/31/2014. So we borrow on the first day of 2012, and we repay back all the interest and the principal at the end of 1, 2, 3 periods. And I call this a timeline of cash flows. So with the terms being interest payable in full at the end of 3 years, let's show you what we mean by an amortization table. An amortization table, we always start with the interest rate in the upper right-hand corner. The interest rate, when multiplied by the amount borrowed of 1,000, gives us $100 worth of interest each period. Since the terms say not to pay any interest at the end of each period until the end of the note term, that if the 1,000 that interest accrues, that 100 will be added to the amount we owe, and that amount we owe now becomes 1,100. In the next period, the 1,100 is multiplied by the amount here in cell F28. That gives us interest of 110 in the second period. Since we paid 0 interest at the end of the second period, the liability goes up by $110, so that we now owe 1,210 at the end of the second period. Now, the third year, interest accrues at 10% of the amount previously owed of 1210. So notice our formula. It's the amount in F28 cell, which is our interest rate, times the previous amount owed in F33. So our interest is 121. Assuming we don't pay anything right at that particular point in time, our debt grows by 121. And so that the very last payment we make on 12/31/2014 is for the principal and the interest. And some people call this a balloon payment because it's a lot bigger payment than any of these other 3 payments, which consisted of 0. So our interest expense now is 0 in that very last instant on 12/31/2014. The entire 1,331 of debt now goes away. The debt has been amortized, and I use this, the debt has been killed. Shall we embalm or cremate? That's just a little joke. The term amortization is based on a French word, mortir, which means to die. An amortization table takes some debt, and over time we extinguish it. Welcome to Lesson 14D. 14D is entitled Case 2, Simple Interest with Interest Paid at the End of Each Period. Let's click on our second tab here, and here we have Case 2, Simple Interest. If you've looked at video 1, you'll see a lot of similarities, but the only difference between Case 1 and Case 2 is that in this case, we borrow $1,000 at n equals 0, but at the end of the first period, we have to pay back interest on the amount borrowed. And the interest rate here is 10% times the amount borrowed, so we're going to pay interest at the end of each period rather than waiting until the end of the third period. So at the end of the second period, the company pays 100 of interest. At the end of the third period, it pays its interest, and it pays the maturity value of the note. Let's take a look at the terms of the note. XYZ Company is the issuer or the borrower. The face amount of the note or the principal is $1,000. The interest rate on the note is a 10% contract or coupon rate or a nominal rate. Same thing. Now, if the $1,000 is borrowed today on January 1 of 2012, then right here at period n equals 0, right here, we have January 1, 2012. At the end of 2012, we come to this point in the timeline, the end of 2013 right there, and the end of 2014 right there. Now, here we can use our amortization table to identify the cash flows and the change in principal so that we can do the accounting for this particular note payable. So here, the amortization table. On January 1, 2012, we borrow $1,000. So we always start in the northeast corner of this with the balance of the debt. The interest rate is stated here in cell F24 as 10%. Like any other debt, the applicable interest rate, when multiplied by the initial amount borrowed, will give us your first period's interest expense. Since we, XYZ Company, agree to pay the same amount as the interest expense each period, the amount paid compared to the interest expense, there's no difference. So the difference between cash paid and the amount expense here is 0. So that if we had a $1,000 debt at the beginning of the period and it doesn't change by the end of the period, we still owe $1,000. Now, in the next period, we pay $100 according to the terms of the note, right there. And it says interest is payable at the end of each year. Okay. The interest expense is going to be 10% of that amount, which is 100. We change the principal 0. And so we still owe $1,000. At the end of the third period, we pay our cash payment. The interest expense is 10% of the previous amount borrowed. Change in principal 0, so we still owe $1,000. And so in the very next instant, after paying that interest payment, we make our principal repayment. We pay back $1,000. Since no time has gone by, interest is 0. The principal goes down $1,000, and hence we've amortized that debt. Hooray! I say here the debt has been killed. I know that's an awful word, but the term amortize is based on a root word mortir, which is an infinitive in the French language meaning to die. And here we've had some debt which we've eventually killed or written down to 0. Welcome to Lesson 14E. 14E is entitled Case 3, Compound Interest, Serial Note. And this is a case where the principal is paid along with interest at the end of each period. And we're going to hold the amount of the principal payments fixed each period in an equal series. And of course the interest will change depending on the balance of the debt at the end of each period. Lesson 14E is part of the overall lessons in 14. Lesson 14 is about long-term liabilities, and lesson 14E comes after 14C and D, where we did case 1, with a case of a note payable where interest was due at the end of the note term. Lesson 14D was case 2 with interest being paid at the end of each period. And lesson 14E is slightly different. This is called a serial note. So let's go to the serial note tab and notice case 3 is entitled Serial Note with Interest Paid Each Period along with Equal Principal Installments. So if we were to look at the timeline here and compare it with cases 1 and 2, notice we borrow $1,000 right here at period number 0. At the end of the first year, we owe interest of $100, which is 10% of the amount borrowed. So 10% of 1,000 equals 100. But we're also going to fix this repayment term such that we're going to pay 1/3 of the principal each period. So 1/3 of 1,000 is $333. So that at the end of the first period, we now owe $667. So 10% of $667 is 67 interest in year 2. Fixing the payment to also include $333 gives us a total payment of, in this case, $400, as opposed to the first year's payment of $433. Now at the end of the third year, we owe interest of 10% of the remaining debt at the end of the second period, and then the remainder of the debt of $334 must be paid. So at the end of the third year, our total payment will be $367. How would the note payable read? It would read something like this. XYZ Company agrees to borrow $1,000 today being January 1, 2012. We're going to pay 10% annual interest rate. But interest is payable at the end of each year in the amount of, in the first year would be $100, along with principal payment of $333 each year. And so interest is payable at the end of each year, but the amount of the interest expense will change slightly depending on the remaining value of the debt. So let's take a look at the amortization table here associated with this note. The interest rate is 10%. The amount borrowed is 1,000. So 10% times 1,000 gives us our interest rate. And notice we put equal $F $25 to indicate that we want to go get the amount in cell F25. And we want to take $F $25, 10%, times the amount right there. So notice the formula here is F25 times F29. Interest expense is 100. We agree to pay 100 plus 1/3 of the principal. So the total payment here is $433. Compare that with the interest expense part of that payment. The rest reduces the principal by $333. And notice our new balance is 1,000 minus $333 equals $667. In the next period, we owe interest of 10% of $667, which is rounded to 67. We add $333 to that, 67 plus $333, so our payment here is $400, thereby reducing the principal once again by 1/3 of the principal, or $333. Notice that we're amortizing this debt in equal series, and the series amount is 1/3 of the principal. So at the end of the second period, we owe $334, of which interest will be $33. The total payment being $333 plus $334 would be $367. So $367 reduced by $33 is the reduction in the principal, thereby amortizing that debt. Welcome to Lesson 14F. Lesson 14F is the 6th video in a series of 11 videos in Lesson 14. And in Lesson 6, we're going to talk about a note payable, and the payment terms are structured so that the payments include interest and principal such that the total payment is equal each period. So we call this Lesson 14F. This is the 4th case in a series of 6 cases, and we can contrast this case with the first three cases by looking at the videos 14C, D, and E. But let's go to lesson 14F, which puts us right here on our spreadsheet, called an annuity. And case 4, again, is entitled Annuity, with interest paid each period along with principal, but we fixed the total payment to be the same amount each period. So in this case, the amount of principal and interest, the specific amounts will differ, but the total cash payment will remain the same. For example, if we borrow $1,000 at time period n equals 0, we can borrow $1,000 with an annual interest rate of 10%, but we can calculate the payments each period to be exactly equal to 402. So the sum of the interest and the principal here in year 1 is 402. In year 2, the sum of the principal and interest is 402. And in year 3, the sum of the principal and interest is 402. Now, how we calculate the $402, I'll show you at the end of this video how to do that with Excel, but it's a really easy technique to do without having to take a finance class to derive this payment using a longhand algebraic formula. So, the note here for XYZ Company, XYZ borrows $1,000. The $1,000 is known as the face amount or the maturity value. The interest on the note is going to be payable at 10% per year. This is an annuity note, and we borrow this money today on January 1, 2012, and the term of the note ends on 12/31/2014. So here we are in the timeline at January 1, 2012. Here we are at 12/31/2012, 12/31/2013, and 12/31/2014. So this is a 3-year note. At the end of year 1, end of year 2, and end of year 3, we've identified the cash flows using the annuity method. So if somebody borrows $1,000 with interest at 10%, repayable in equal annual amounts, the bank will calculate a payment 402 total, $402. Now this is different in our first 3 cases when we paid either 0 interest or 0 principal at the end of each period, or we paid a series of equal principal payments. Here, let's set up an amortization table such that the amount we borrow, $1,000, at a 10% interest rate will be used to calculate the equal annual payment. Given that the equal annual payment is 402, and just take my word for that for a moment, the interest part of that is going to be the amount of the interest rate, 10%, times the initial amount borrowed. So in year 1, the total interest is 100. If the total payment is 402, we're going to knock off $302 of that amount from the $1,000 initial loan. So that 302 will be reducing from $1,000 down to $698. At the end of the next period, on 12/31/2013, we pay again the annuity amount, 402. Interest is 10% of the previous amount borrowed, so 10% of 698 is 70. The change in principal there, we knock off an extra $30 of principal compared to this period, and so our principal falls down to $366. Now notice, the interest expense falls over time, but the amount of principal extinguished or amortized gets bigger over time. Finally, at the end of year 3, we pay our last annuity of 402. The interest expense is 10% of 366, or 37, and we amortize $365 or $366, and I'm rounding such that that falls to 0.